Select the major product of the following series of reactions. So we are starting here with a molecule that has a ketone and an ester, and specifically this is an acetoacetic ester. And what we're doing here is an example of the acetoacetic ester synthesis. And so we've got the ethyl ester, so we're going to use ethoxide as a base, and the first thing that's going to do is it's going to remove the most acidic hydrogen in the molecule, which is going to be one of these two hydrogens in between the two carbonyls. So you can have the ethoxide, and it is going to remove one of these two protons, giving you the enolate. So that's the first step. And in the second step, you're going to have that enolate attack the methyl bromide. So we are adding a methyl group to this carbon atom. So we've added a methyl group, and we still have an acidic hydrogen. So when we do an acetoacetic ester synthesis, we have the possibility of, if we want to, replacing both of these hydrogens with alkyl groups. And that's what we're doing here. So we replaced it one hydrogen with one alkyl group, and then we're going to take it through the same series of reactions. So you're going to make an enolate again. So using more ethoxide. So we're going to make an enolate once more. So it's still the hydrogen in between the two carbonyls that's the most acidic. And so this just gives us a different enolate. And now we are adding in a 4-carbon atom alkyl halide. So in our next step, what we're adding in, we've got the Br, and it's attached to this 4-carbon chain. And so we can do the same sort of SN2 attack, and we're going to add this butyl chain as well. So now we're going to have both the CH3 and a 4-carbon atom chain, which I'm going to go ahead and draw this as a skeletal structure because it's going to be a little bit easier. So 1, 2, 3, 4. Okay. So let's go ahead and number these carbon atoms that we've added, or mark them in some way. So here's the methyl group that we've added, so we can see that all the way through. And then I'm going to number this 4-carbon chain. So we have 1, 2, 3, 4, 1, 2, 3, 4. So that's what's been added. And then what we're going to do here in this last step is hydrolysis and decarboxylation. So the first thing we're going to do is we're going to hydrolyze this ester to give the carboxylic acid. So we still got the CH3 group, and we still got this 4-carbon chain. 2, 3, 4. Okay, so I'm going to go ahead and kind of indicate these again. And when you decarboxylate, so when you keep heating this up, you can lose that carboxylic acid as CO2, and you're going to end up with a substituted acetone, essentially. So the substituted, this is the acetone that we're talking about that's coming from your acetoacetic ester. So we go ahead and number those carbons as well. And so when you lose CO2, this is what you're going to have. So you're going to have, there's your first 3 carbon atoms that we've numbered here in pink. And then I'm going to keep going with this longest chain. So I'm going to put these 4. So 1, 2, 3, 4, and that's coming from this group. So I'll put these numbers on here. And then also on carbon 3, this is the carbon that was in between the two carbonyls initially. You also added that methyl group, so I want to make sure you put that methyl group on there. So there it is. Okay, and so this is the same as this first option here.